All right, thanks, Amos. I'm Dave Schmidt, and I'm excited to be here. This is a very similar presentation to one I gave at the annual conference for PFI a few years ago, and have a few more observations based on the last few years, but generally keeping things the same. So my wife and I run Troublesome Creek Cattle Company. We've been doing this since about 2012, and have some experience at this point. And I wanted to emphasize that everything in this presentation is based on what I've had experience doing. So I can't be comprehensive and cover the things or the methods for water that I haven't tried. There are definitely lots of alternative ways to do this, but this will focus on what I've done. And my hope is that this will be a very practical presentation with costs and tips and things that you could implement yourself. So that's the goal. All right, next slide. My goal is to talk about some of the advantages of the above ground waterline system that we're using. I'll then talk about what we do currently and how it's set up specifically for our farm, but try to keep it general enough that it's still relevant for anybody else. Winter is always a special challenge for above ground water. So there will be quite a bit of discussion about winter and dealing with freezing water. Next, I'll talk about some of the specific issues that we've had. And then finally, some ideas to improve our system and some of the recommendations for people that are interested in starting from scratch and learning from the mistakes that Meg and I have made over the years. Next slide. Okay, so we are based east of Exira, north of Anita, about an hour and a half straight west of Des Moines, an hour from West Des Moines, in Audubon County. And our topography is rolling hills. It's not flat, not as flat as central Iowa. It's not as hilly as parts of northeast Iowa, but it's got some rolling hills. Next slide. All right, so the advantages, as I see it, for the above ground water system as we've implemented it are high stock density grazing, and I'll talk about that next. And then the key thing that's really let us dramatically improve our grazing system is we can put up back fences. So rather than letting cattle trail back to water points over a period of days or even weeks, like a lot of people do, we can limit the access to what they've already grazed. And we've seen that improve our forages and our soil. And I think that's probably the biggest reason to put the extra effort into distributing your water like this. It also has the advantage of limiting cow trails because cattle are not trailing back over huge pastures. And it limits or distributes the animal impact. So you don't have the whole herd going to a single point, and when it's wet, tearing it all up and making a huge mess. Even if that happens with our system, they're most likely going to be moving within a day or two. So that impact is minimized and distributed. Next slide. So if you're not familiar with high stock density grazing, here's an image that kind of gives you the idea. The cattle started out grazing to the east side of this drone picture and are working their way to the west. The strip that they're in the middle of the picture, they've grazed about half of the forage there. So it's kind of in between the light green and the dark green. The dark green is where they're moving into that hasn't been grazed yet. And you can see that we've got a forward fence and a back fence. So they really can't go outside of that area. And towards the top of the strip that they're in, you might be able to see a little black, brown, or oval water tank. So they have to go to that point for water. As they move down this field, we would move the water tank along with the cattle. So they're not having to go back clear to the far end of where they've grazed for water, which is what we had been doing. And then this also illustrates something else I'll discuss too. The field to the north is there's a fence line between where the cattle are and the field to the north, or to the upper part of the picture. The water line is running along that field boundary. So if you can run your water lines to take advantage of field boundaries, then you can basically have the advantage of watering both sides of fences, rather than having to run water lines down the middle, which might be the first thought people have. But keeping those under fences is a big advantage. All right, next slide. So we generally have 60 to 70 animal units on the farm at any time. We've been doing grass-fed beef for over 10 years now, and we don't always know exactly how many animals there are. It depends on what we've got in terms of grass finishing animals. Our number of cows is typically 25 to 30. So depending on what time of the year it is, we'll have those cows plus their calves plus last year's calves that are now yearlings that we chose to keep to finish on grass. Our goal is to start grazing in mid-April and try to get all the way into late December or even into January sometimes. Totally depends on how much forage is left to stockpile in the late fall, early winter. And it also depends on the weather. So once it starts getting cold, if it gets colder and stays cold earlier than expected, because of the way this water system is set up, it's pretty hard to stay grazing after that point. So that end date for grazing is typically constrained by forage availability and then also temperatures for water distribution. We have a single shallow well that supplies water for both the house and for the farm. So far, that's worked really well. Even with the last few years of drought, we've managed to not have any shortages of water. We don't have any consistent surface water. So we rely entirely on this one well. We have 5 hydrants that are located in different spots that have buried below the frost line, buried water lines from the well up to these hydrants. We also have 2 fixed water tanks, one near the lots where we keep the cattle once we bring them in after the grazing season, and then another one in another spot where we sometimes keep them in winter. The number 9,000 feet is a little out of date. I've added some more water lines since this was originally presented. We've probably got close to 10,000 feet now of above ground water lines. That gives us probably close to 50 temporary watering points distributed over the entire grazing area. Next slide, please. And the map on the right shows in red our property boundary. We can currently graze about 112 acres. And the point of this map is to show where the hydrants are. The well is pretty much in the center of our property, and the hydrants are the source for these 5 different water line setups. So they're all distinct. We don't have a single unified water system all coming from a single hydrant. Instead, we take advantage of where each hydrant is, and then whenever the cattle are in that area, let's say to the north, we disconnect everything from the other systems and move our hoses and water tanks and everything to that hydrant. And then we'll use that until they move on to another section. But each of these different hydrants supplies roughly 2,000 feet of water lines, and that has worked really well. I'll talk about this in a little bit, but I do feel like those distances are probably getting close to the max. You can certainly pump water farther than that, but there's issues with supply and pressure if you get too much past that, especially depending on your topography. Next slide, please. Here's the same area zoomed in. This is just to show that each hydrant is kind of the source for a separate set of water lines, and to show that we've pretty well covered most of the property with water lines, so there's access in most points around the farm. There's a little bit that's not in this map that I added a couple of years ago. Next slide, please. So this is to maybe help other people designing systems from scratch. From the well, our current system goes about 2,000 feet south. We also go more than 2,000 feet to the north. The point of that is to show not what the absolute max is, because I don't know what that is. It depends on your well pump and your topography. But at least in our case, we can go that distance without too many problems. As I said, we've got some rolling hills, nothing dramatic, but we do have about 110 feet of elevation gain in certain areas from where the well is, which is kind of a low point, up to some hilltops where the cattle graze, and we lose about almost 50 pounds per square inch of pressure. So that does affect the function of float valves. It also affects the rate at which water tanks refill. On the other hand, we have some areas where we go downhill from the well and we gain about 30 PSI. So if you've got fittings that are not designed for high pressure, that can cause problems. And the flow is improved, but there can be issues on hot days, especially when the water expands, with maintaining the fittings and making sure they don't leak. Our particular well is about 30 feet deep. Generally, we've got water that's only maybe 10 feet down now, given a few years of drought. One important thing that has worked well for us is to switch from a 40 to 60 PSI pressure switch to 60 to 80. I believe most people use 40 to 60. That's pretty standard. Our well is a quarter mile from the house, so we wanted to make sure we had adequate pressure in the house for showers and things like that. It also helps us distribute water out through these water lines. So I would recommend a high pressure switch in your well pit for your water pump. Next slide, please. All right, so generally our system keeps up really well. Even in the summer when hot weather is causing the cattle to drink the most, it's also when cows are at peak lactation and they've dramatically increased their water intake. I've estimated we're using probably 800 gallons a day at that time. As I mentioned earlier, the pressure can be too low at some of the high points and some of the furthest away points. That causes problems when tanks don't refill fast enough, and the cattle will tend to mob those tanks, and then they'll all try to drink at the same time, and then it causes all kinds of problems when they push the water tank under the fence, or they tip it over, or they just start pushing too much and causing trouble. Other areas where we've got too high of pressure, where the grazing areas are downhill from the well. Occasionally on hot days, we'll get some fittings that leak, and that causes muddy areas and a mess. Sometimes we'll actually blow apart fittings, and they don't break, they just force the water line out of the fittings, and then you basically you're pumping all your water out into the pasture, which is can be a real disaster. So pressure is always something to be aware of as you lay out your system. Right at the well, we've got 15 gallons per minute of water flow. But just for reference, so 2,000 feet away, uphill, it might only be 5 gallons per minute. And that's kind of inadequate, I would say, for this number of cattle. In those cases, when we do end up waiting, sometimes it's just a waste of time. Somebody will have to stand there for half an hour or longer sometimes and make sure that the cattle, that the tank fills enough that the cattle can't push it, or just letting it completely fill so that the cows can drink it down, and then you have to stand there and wait for it to refill. So ensuring adequate supply everywhere, even the farthest points out, is worth the time to make sure that's designed well. Next slide, please. I didn't know about this feature in Google Earth when I first designed our system, but you can get elevation profiles for various tracks along your grazing area, which is a really handy feature. If I had known about this then, I would have taken advantage of it to think about routing water lines in ways, so you're not necessarily trying to get water to the highest points, and also trying to ensure that you've got easy places where you can drain water lines for in the fall when the cold weather becomes an issue in natural dips in the topography. So it really helps expedite the draining process if you have areas that you can easily disconnect in your water line to allow it to drain where there's already a dip in the topography. So I wish I'd known about this, but this is a handy tool for if you're starting out to help design your system. Next slide, please. Our water lines are all 1-inch high density polyethylene water lines, and ours happen to be 160 PSI rated. I don't think we need to have quite that much. I think there's higher and lower ratings. I don't know if I would necessarily go lower than 160 PSI, but I don't think it's necessary to have water lines that are higher, have higher rated values for pressure than that. The elevation tool I got from Google Earth, just through the website, or I think I downloaded it and ran the application on the computer, but that was a handy way to get the elevation profiles. You can buy different lengths of this water line, and it obviously depends on the number of animals you're trying to water and your topography and just how large of area you're trying to cover. But in my experience, 500-foot rolls are about the max that you can unroll by hand easily with one person. The 100-foot and 300-foot rolls are a lot more convenient. The couplers to connect short lengths are not especially expensive. So there's really, and I don't think the price varies with length. So there's really not too much advantage unless you're doing thousands and thousands of feet to having shorter lengths. All of our water line, as I mentioned, is 1-inch. I think that's adequate in our case. I would recommend going above what you need if there's any doubt. It's better probably to have excess capacity for if you expand beyond what your current number of animals is, than to have to completely redesign your whole system and replace all of your water lines if they're too small. The fittings that you buy must match the outer diameter. So if you buy 1-inch water lines, you'll have to buy 1-inch fittings, obviously. So all of our fittings are 1-inch. We bought water lines from 2 places. So we have one single field, unfortunately, that has slightly different water lines, which means different fittings, because the fittings must, the outer diameter. So the pipe is sold based on the inner diameter, which is always exactly 1 inch or 1.25 inches or whatever you have. But the outer diameter varies depending on the manufacturer and the pressure rating. So the fittings that we have for most of the farm don't match on this one field, even though it's all 1-inch pipe. So be aware of that. In this case, that field has water lines from PowerFlex, so we had to buy water or fittings that also came from PowerFlex that only work with that water line. Everything else came from Jacobson Incorporated, which is in Adair. It's pretty close to us, so we could just go and pick up the rolls of water line really easily. Next slide, please. These water lines are very durable, and we haven't had any issues so far. When we initially bought them, the guy from PowerFlex said that he ran a dairy operation and had water lines running across the gravel driveway that got driven over every day by a heavy milk tank truck, and did that for years and never crushed the water line or never punched through it with gravel. So they're pretty durable. I've run over ours with a speed rake and a disc mower. It can handle a bale cart, with 6 bales or 8 bales. I have not tried running over it with a hay baler. I've always been nervous about trying that. So If we don't make a lot of hay, but if we do, I actually pull the water lines off that field just to be totally sure that we don't accidentally get a water line caught in a baler and cause a huge mess. I do try to avoid driving over our water lines if it's running over an area of gravel or concrete. I think it would eventually, even though the PowerFlex guy said he didn't have problems, it just seems like you're asking for trouble. So if it's easy to move the water line, disconnect something and pull it back, that's what I do. I've tried it with a side rake. A side rake definitely will catch the water lines and drag it around. So I don't recommend it. And then the one weakness in this kind of water line is that they will kink. So if you flex it too much, it'll kink, and that's a permanent weak spot in the water line. You can't really undo that. And it'll stretch the water line right there. And if it doesn't leak immediately, it probably will leak eventually. So you have to be careful about kinking it. It's pretty hard to kink it unintentionally, but if you're in a hurry and are trying to fold it back, for some reason, it's possible to kink it. A few years ago, it was about 50 cents a foot. I actually don't think it's a whole lot higher now. This was at Jacobson in Adair for 1 inch. The prices do go up pretty dramatically with the inner diameter. So even though I said I recommended excess capacity, it's worth taking the time to do some calculations and estimate how big of a water line you actually need, because of the cost. It does add up pretty quickly. Next slide, please. Okay, so that was the water line, and then the fittings that go on the water line. We have 2 different sources, as I mentioned, to go with the 2 different brands of water lines. K-Fence Incorporated, which is out of Winona, Minnesota, I think, somewhere in southern Minnesota. They sell Agrifit and Plasson brands. Great parts, highly recommend them. And then the other parts came from PowerFlex. Those also work really well. I don't have any strong opinion either way on which are better. They're just a little bit different, but basically the same design, and they're both durable and similarly priced. So whatever works best. Next slide, please. Here's an example of some of the fittings that we've used. There are other styles and additional options for configurations, but these are prices, I think, from K-Fence a few years ago, so I'm sure they're a little bit higher now. And these are all 1 inch fittings that work with our system. Prices go up with the hose diameter or the water line diameter. The couplings are what you need to connect 2 pieces of hose together, or if you cut it or kink it, you can cut out the damaged section and splice it with one of those couplers. And a hacksaw works really well to cut through the water line. It's pretty easy. The 1 inch offset is what you need to have in your water line everywhere you've got a water point. So the upright portion of that T is where you'd connect one of the valves to fill your water tank. So we've bought a lot of those. The top right corner, the 1 inch T, that's to connect to branch. If you want to have branches go off from your main line, an easy way to do that is with one of those T's. The elbow is handy if you want to go around a corner. The adapter at the end is what you need to go from a garden hose into the water line. So everywhere we've got a hydrant, we have to have one of these adapters to connect from the garden hose to into running water into the water line. And then finally in the bottom right corner, there's a shutoff valve. I've got one of those. I haven't actually tried it out. I think it would be handy in certain cases. It also seems like something that could break. So it could be a pretty handy tool. I don't think it's necessary for most people. Next slide, please. And as far as I know, this is probably the only option, or certainly the most standard option, for taking water out of your water line to fill your water tank. This brand, these are made by Plasson. This is pretty much what everybody sells. Ken Cove sells these, garden stores or farm stores sell these, both PowerFlex and K-Fence sell these. The basic idea is you'll connect your garden hose to the key in the bottom on the picture. And then that snaps into the valve. So anywhere that you want to fill a tank, you'll just take a garden hose, snap it into that coupler. And that's that. And those work really well. Those plastic caps on the top usually break off after a while, and it doesn't matter, but they are kind of nice to keep dirt and dust out of the valves. And then if it rains and freezes, I've never had one crack, but yeah, ideally they'd have the caps. Next slide, please. Here's what it looks like out in the pasture. I don't remember where this was, but that shows how much pressure we had at that particular point, just enough to kind of shoot the water out a little bit. This doesn't have the garden hose connected into the key, but that's how the key snaps into the coupler. Next slide, please. Okay, so once you've got your water line set up, you need to be able to get water from the hydrant into the water lines. I've always used a garden hose for this, and ideally 3/4 inch hose. I have used 5/8 inch, but then your garden hose kind of becomes a bottleneck to the flow. So ideally, I'd recommend a 3/4 inch hose. If you've got 2-inch water lines and you're pumping a lot of water, you might want to figure out something besides a garden hose so you're not restricting your flow at those points. Unless you want to have your water tanks be a long ways away from your water points, which is great if you want to do that. I would recommend a less than 50-foot garden hose just so there's less to drag around and handle. That's just for convenience. For every place where you're running water from the hydrant into the water line, you'll need one of these female adapters. That was in the picture a couple slides back. That lets you go. That's a compression fitting from the water line into a threaded end. And then into that threaded end, you'll have to connect one of these pipe thread to hose thread adapters. I recommend the solid ones like in that picture. You can buy swivel ones at the farm stores. Those are convenient. They're easier to connect, but they don't last long. So these solid brass ones, they never really go bad, but they are required in our case. I don't know how else you could design this, but at least in our case, we have to go from the hose thread on the garden hose into the pipe thread, which is what the compression fitting components always use. Next slide, please. Okay, and then to go from the water lines into the tanks on the other end, you'll need the quick coupler valve and the key that I showed a couple slides ago, and then the same kind of adapter. So at least at this time, about 3 years ago, each water point where you'd want to fill a tank is about $20 worth of fittings. So if you break one, which occasionally happens, sometimes I'll accidentally pull the hose too much to the side and snap off one of those quick coupler valves. It's not terribly expensive to replace it. If you're putting in hundreds of these water points, you might want to think about, how to keep the cost down. But every point needs the valve, the key, an adapter, and then a T in your water line to let you screw the quick coupler valve into the water. Next slide, please. All right, then once you've got the water coming out of the water line into your garden hose, you'll need a tank of some kind. In our experience, what's worked best is about 150-gallon tanks. I've always used rubber tanks. They are really tough. They can handle uneven ground. They don't have to sit on a perfectly flat surface. And I'm sure there's other brands out there. Tough Stuff is who makes the tanks that we have. We've just gotten them from local farm stores. I like to run the fence so it runs halfway over the tank, the long way. These are always oval tanks. And that lets about 6 cows drink at the same time. So if you've got a whole lot more cattle than that, you could use multiple tanks or maybe a different size tank that's a lot bigger. But that's what works well for us. There's really not too much advantage in having bigger tanks, and they're also heavier and harder to move around. There's always a drain hole in these tanks that they come with, but you have to cut your own hole to put a float valve in. So a few years ago, yeah, 2016, more than a few years ago, I guess, they were $100 for a tank. I think we bought one more recently and it was $120 maybe. Every tank needs a float valve to prevent the water from just running over the top once it's full. There are all kinds of options here. I think what I recommend is pretty standard, and that's a Jobe Megaflow float valve. You can get these from the same places I listed. Also, Ken Cove carries these. A couple of years ago, they were about $60 each valve, so they're not cheap, but they do last. Occasionally, you can take them apart, clean the screens if they don't flow. If eventually the flow is reduced out of that float valve, you can sometimes find some algae or other debris in there and clean those out. I highly recommend having a spare parts kit on hand. If something fails or breaks and you don't have the replacement part on hand, it can be a real mess because you can't get water out there. So it's worth just buying a few of those spare parts kits to keep on hand, whether you think you'll need it or not. Eventually you will. Next slide, please. So here's an example of what it looks like. In this case, we've just got the garden hose running straight into the tank rather than through the valve. You can see on the bottom, in the middle of the tank, there's a thread adapter there, which normally we'd screw that hose into that adapter. In this case, we wanted to get as much water in there as fast as possible because the cattle were thirsty. And you can see 6 is about as many animal heads as will fit in the tank. And then I like to keep the fence pretty much right over the middle so that nobody does something dumb like jumping into the tank. If on a hot day, sometimes they like to, get their feet in the water tank. Once they do that, then you got to drain all the water out because the water is contaminated and they won't drink it. So it's kind of a nuisance. So even though I could probably have more cattle drinking at the same time, it's nice to be able to control access a little bit with the electric fence this way. Next slide, please. All right, winter. So a big challenge with above ground water lines like this is freezing weather. Spring is easy, but by late November, usually it's getting cold enough, at least in this part of the state, that we have to change what we do. Getting down below freezing is not really a problem. In my experience, 28 degrees is kind of the threshold, especially if you're coming from warm weather and the ground is still warm. The ground will keep the water from freezing too hard or from freezing at all, even if it gets down to 28 for a few hours. Even if it gets into the low 20s and it freezes a little bit, in my experience, that's okay, as long as it warms up enough the next day that it'll thaw out that ice and the water can start flowing again. Once we start getting down into the lows at night, into the mid 20s or so, then I typically will drain the water lines every day, which is a pain. So once it gets to that point, then the end of the grazing season is quickly approaching because it's a lot of labor to drain the water lines every day. And that usually happens around Thanksgiving in our case. One thing you can do to extend your grazing season when you know there's a short-term cold spell is to just drag a few tanks out there and fill those all up. And hopefully that's enough water for a few days so you can avoid having to run water for those cold days and having to drain the water lines. So that's let us kind of skip through some of those cold snaps. Next slide, please. Draining water lines has to be done at the end of the season for sure, but if you want to push your season out and drain it on a daily basis or whenever it gets cold enough, it's kind of a pain, especially if you wait so long that it's turning into slush. Then once you've got slush or even a little bit of ice in your water lines, it's really hard to get that out. You might have to just wait till let it freeze solid, and then hope that the next day or a few days it's warm enough to thaw that out and get the ice out. I have tried to use a torch to thaw it out where I know there's ice, if you can feel it, and that works well if you're careful and don't melt the plastic water lines. So far, we've never actually burst a water pipe, or we've never broken a water tank by letting it freeze. There's been areas where it's been frozen solid and it'll stretch the pipe a little bit, but it doesn't necessarily split it. I wouldn't recommend doing it routinely, but a few times is not going to ruin your water lines necessarily. In our experience, the garden hoses are what freeze first. They are always kind of the weak point in this whole system. And typically if the weather gets cold, because they're so much narrower, those are what freeze. And it's easy to drain those, so there's no reason not to just disconnect your garden hoses at night and drain those. I did finally cut a plastic water tank. I was trying to break some ice with the hatchet and managed to slice through the plastic. In my experience, once the high temperatures stay below freezing, then you might as well just wrap it up and be done at that point, and then drain the water lines. I like to reconnect the water lines even if I won't use those again until spring, because sometimes mice will go into those water lines, and then in the spring you find mouse parts clogging up your valve. So better to just keep them out of there. Next slide, please. Here's what it looks like when it freezes. In this case, it happened to freeze part of the string that attaches to the float valve, and I accidentally ripped that float valve off when I was breaking the ice. So normally if a few inches of ice build up on the sides or on the top of the water, it's not a big deal, as long as you don't happen to freeze something like this into the ice. Next slide. This one shows what it looks like when you get some ice built up. Then you have to find where you should disconnect the water line and hope that you can build up enough pressure that it will shoot out all these little segments of ice. Totally depends on the temperature. Sometimes it works well to get all these out. Sometimes if you wait just too long, then you're kind of out of luck. Next slide, please. Here's what we do once we're done with above ground water. This is a concrete tank that has a wood burning tank heater in it. This is just an old welding tank that's got a cap hinged on top. And then there's another tank below the water that you can't really see, where you can put wood in there and burn the wood, and then the smoke comes up through the chimney. Incredibly inefficient. Most of the heat goes up through the chimney and out, but it does keep the water from freezing. And typically the temperatures have to get down consistently into the teens or below before we have to start burning wood in this to keep the water open in these concrete tanks. Next slide. Water temperature can be a big issue on hot days. Sometimes it's so hot that it's too hot to touch. In that case, I'll try to just drain out a bunch of water, drain all the hot water out, and wait for the well water to come out and replace it. Water pressure, too high and too low, is a common problem. Winter, mentioned that already. Fill rate, make sure you've got the capacity to get water in sufficient volume and rate of flow to keep up with the cow demand. Some of the water points that are uphill from the hydrant, when you turn the hydrant off, all the water in the water lines, which can be, in our case, 80 gallons, quite a bit of water, flows back down through the hydrant. Those hydrants are not really designed to disperse that much water. So I put a shutoff valve in there and manually turn that off to keep the water from draining back down through the hydrant. any risk or any system has the risk of flooding. On a hot day, especially if the cattle find a wet spot, they will take full advantage of that and make a nice muddy spot, which can last for a really long time, unfortunately. But even a slow leak overnight or for a couple days can flood a pretty large area. So that's always something to watch for. When we run cattle water on hot days, sometimes we have low pressure in the house, and it's just a disadvantage of having a single well for both the house and the farm. Cattle mobbing on hot days, they can really, as they're jostling each other to get to the water tank, they can end up really tearing up the pasture. So we try to make sure they're never without water for very long at all. When we're moving between paddocks, sometimes we have to wait for the tank to fill. It seems like they always want to all drink at the same time when you're refilling it. And that's when they can sometimes mob and tear things up. A weak point for us is this whole system is entirely dependent on electricity and our well. So if something fails there, we're pretty much dealing with an emergency and have to immediately fix it and drop everything else. Next slide, please. Garden hoses, yeah, these almost always leak. They take a lot of pressure, especially on hot days and in low points. And whether it's the hose itself leaking from kinks or from the fittings, they only seem to last a year or two, in my experience at least. The rubber kind of standard garden hose, those are a pain when it gets cold because they're hard to coil. And we end up moving those with the cattle, so they're, you know, packing up everything once a day or so. Next slide, please. What we found works. Oh yeah, this shows what happens when you've got a small leak in a garden hose. It doesn't look like that much water, but it will definitely pool and cause a wet spot that can turn into mud once the cattle find it. Next slide, please. Some recommendations. We've talked about this over the years, burying some of these water lines, not fully below the frost line, but deep enough that we can extend the grazing season even a few weeks or a month out. I think it'd be worth doing it. We just haven't gotten it done. One thing we need to do soon is add more fixed winter watering points, whether that's with, yeah, it would be with some kind of frost-free water and buried water lines that are 4 or 5 feet deep. So that would give us the flexibility to keep cattle out from our main lot area throughout the winter, even if we're feeding hay and not really moving. It'd give us some extra points where we could keep them out of the lot. Surface water, we just don't have the topography, but ideally there'd be some reservoirs or small ponds that would give us a buffer in emergencies where we had problems with the well or electricity. I'd like to try using some smaller tanks just because they're easier to move. I'd like to figure out a way to rig up a temperature valve that would let us automatically shunt hot water off if it got above a certain temperature. I don't know if there's such a thing, but it'd be handy. Oh, the next picture shows a float valve that John Schulte made. He's a PFI member in Norway, near Norway, Iowa. Next slide, please. And that basically prevents having to drill a hole in the bottom of on the side of your tank. So he just hooks the garden hose up, tosses this into the tank, and that plate on the bottom holds it at the bottom of the tank. And then there's the float valve, just like one of these Job valves. But it's easier for him to leave the garden hose hooked up, and then he just takes the whole thing out separately from the tank. So that's something we've looked into, haven't gotten it implemented, but it could be an improvement. Next slide, please. So some recommendations based on my experience. We always have laid out water lines under the interior fences between fields that lets you get water to both sides of the fence. It also minimizes the hassle if you're doing any operations like with machinery, so you don't have to move the water lines. I like to move keep the paddock fence over the tank, whether it's the long way or the short way. That's an easy way to keep the cattle from trying to stand in it. As I mentioned, I think for most people, 1 inch is the minimum diameter. Don't really recommend less than 3/4 inch garden hoses. At least in our case, trying to have a quick coupler valve every 200 feet is a nice guideline. Doesn't have to be that, obviously, depends on your situation, but for us, that's a nice way to ensure that we've got the flexibility without excess, money and time invested in excess infrastructure that you don't need, but it lets us at least cover every area so that they don't have to go back more than 3 days. That's a nice guideline. This last point, I used to paint the fence posts near water valves to try to find those valves easily. Once the grass grows up over the valves, I've wasted a lot of time trying to find those. And then last year, what I did instead was I took duct tape that was neon pink or neon orange and made a nice flag on the post. And those went through the winter really well. So I'm hopeful that those last for a long time to save time and effort trying to find the next water valve down the line. The paint it worked well, but it faded and wore off really quickly. At least on our fiberglass post. Next slide, please. There's a few years ago trying to spray paint some of these posts. Next slide. Oh, yes. So spare parts, not just for the valves themselves, but fittings, especially the keys to connect in your quick coupler valves, drain plugs. If I've done this several times, every time you move your water tank, you have to drain it. If you accidentally dump the drain out with the drain plug, and can't find it, then you've got to go find a new drain plug. And if you don't have one, then you don't have any water for the cattle. So having a few spares on hand is really nice. The drains that most tanks come with are really small, maybe a 1/4 inch or no, 1/2 inch hole. I like to drill those out a little bit bigger and then buy a different drain plug to help drain these faster. Otherwise, you have to stand there and let the water drain out. I generally only fill these tanks about halfway so that it's not an issue sitting on a slope. Otherwise, the water will just run out on the low side of the tank. So having the excess capacity is kind of nice just to allow those tanks to sit at pretty steep angles sometimes. Trying to put those couplers in areas where there's dips to make it easy to drain would have been nice. I didn't think of that at the time. And garden hoses is always an issue. Next slide. I think this shows some of so these 0G flexible, I don't know what you call them, 0G hoses, I guess is the maker. But these are the best we've found so far. They're definitely not perfect. They're expensive, but they are really flexible and lightweight, which is really convenient. The fittings don't fail in my experience. The hoses themselves can be punctured. So, and the nice thing is they have a warranty. So we've taken advantage of that to replace a lot of these hoses. But if there's a better option, I'd like to know what it is. But this is the best we've found so far. I don't think we've got 75-foot hoses. Those are a little bit too long. I don't think they make a 3/4 inch, 50-foot. I haven't seen one yet, at least. Next slide, please. Here's just some more information on these hoses. The flexibility in cold weather is really nice. Fighting with a cold rubber garden hose to try to roll up to get into your ATV when it's cold is amazing. That's a big advantage in my mind. Thanks. Next slide. We used to do this. We'd fill a 1,000-gallon water tank and drag it around with the tractor out behind the cattle. It works. It's just labor intensive, and you've got to drive on your pastures with a lot of weight and compact your soil. You can't really do it when it's really wet out. And at least in our case, this much water was maybe 3 days worth of on a 3 days worth of supply. So you're constantly having to haul the tank back and refill it and drive it back out. So I've never regretted putting in this above ground water system to replace other alternatives like this. It's been worth the time and money. Next slide. I think that's it.
All right, thanks so much, Dave. Folks, feel free to toss your questions in the chat. I've seen a couple coming in. I'll just kick us off here. Dave, would you say that you designed your grazing plan based on your water lines, or did you design your water lines based on what you wanted your grazing plan to be?
Yeah, good question. I think the latter. We were grazing the way we focused on grazing first and making sure we had the fencing to allow us to do high density stock grazing. And then went back and added the water infrastructure to allow us to do that right. For a while, we were trailing back to fixed points for water, which kind of defeats the whole purpose. But yeah, we designed the water after all the grazing setup was done.
All right. We've got a question here from Emily. How low can the water in the tank get before the cattle can't reach it?
The cows can reach it anytime. They will drain it till it's dry and basically lick whatever they can get out. So they can salvage any water that's in there. The calves can't really reach it well until they're maybe a month old, even if it's not down very far. It does seem to work pretty well. Once those cows are really, or the calves are really needing to drink water, then they're tall enough that they can reach down, and I'd say even halfway down on these 150-gallon tanks, they can access the water. Once it's below that, they have a really hard time getting it. They can't reach it. As long as the tank is at least half full, I'd say.
Ethan, in reference to your flagging of the posts near the couplers or the water access, Ethan says that he uses those fiberglass rods with the reflectors on that you see near driveways, and he can find those easily in the dark with a headlamp as well.
Great idea.
Justin asks, how many head drinking per tank in the fall? We've used never kink hoses held up very good, even the ends with our hard water.
Cool. Yeah, I'll check into that. I haven't heard of that kind of hose. In the fall, we've probably got that's probably the max because we haven't taken any of the finishing animals to the locker yet. And those calves they're not weaned, but they're really not drinking much milk, so they're fully dependent on the water. So the number of head, I mean, it's probably something like 75 animal units. The number of head is it's probably 30, 80, 80 head, counting calves. So, smaller animals too, but something like that.
Keep your questions coming. We've got just 3 more minutes or so before we've got to let Dave go. Dave, do you ever test your water for anything, or because it's the same water that's coming into your house, you trust it?
Yes, we haven't for a few years. The fact that it's a shallow well is, yeah, it's convenient, but it's problematic too. We have had issues with, I forgot the kind of bacteria. There's one kind of really common bacteria that's not really a problem. E. coli, we have had, I think once in the Midwest labs who did the water test, basically said, never drink this water. don't ever even think about drinking this water. So we shocked it and tried to get rid of that. But that is a drawback. The water is that shallow well water is fairly vulnerable to contaminants. We have tested it for herbicide residue because all of our land was formerly crop ground and not picked up anything. It's not terribly hard water. Other than that, I guess I don't really know if there's any other contaminants in
Kelly asks, what is your backup plan for when the electricity does go out?
there. That's a great question. Yeah, the backup plan has always been to go to the neighbors, and I've already asked and know that I can fill up water tanks, that wagon that I showed the last picture, and haul water out. And he said that's fine for a while if we need to do that. But if his electricity is out too, I think what we'd have to do is go down to the river or the creek, which is a mile away or so, with a gas pump and actually suck water out, like build a little dam or something and suck water out into that tank in the wagon and then haul water that way. So that would not be ideal. It might not even work in some situations, but that's probably the best we'd have options that we have if we were out of power. We've got generators and other backup electricity sources. So if we came down to it, I think we could power it ourselves for a little while at least.
And Kelly, as a follow-up to you or the general audience, asking about a solar backup system that you could use for a standard electric well pump.
Yeah, we've got neighbors that have solar power for their water, and I think it works really well. I'm not sure if it can be backup. I think it's one or the other probably, because our pump is an AC pump. And if you had solar, I think you need a DC pump. So I think you'd have to pick one or the other, unless you have an inverter. And you could invert your DC solar power into AC and keep an AC pump. But I'm not an expert.
Ethan asks, how did you select your pipe diameter? Did you work with anybody on the calculations like water flow per head of cattle?
I didn't work with anybody, but I used a book. I think it's called Grass-Fed Cattle or Raising Grass-Fed Cattle by, forgot his name. It ends in, his last name is Ruchel, I believe, Ruechel. And he goes through a lot of nice calculations and recommendations for somebody starting out. And he had a whole chapter on water pressure and diameter and flow and some of the math needed to help come up with those guidelines. So sorry, I can't tell you the exact name of the book, but I think you can find it based on that.
Just like one more minute for questions. So if you've got something burning, toss it in the chat. Otherwise, this presentation will be posted in a couple weeks on our website. And Dave's email is at the end of it, so you can find it there. There is one more question. Let's see. Oh, there are a couple more questions. Ross asks, how do you mitigate algae buildup or clean the tanks?
Yeah, that's definitely a problem. It doesn't really, there's really no problem until the water, until the sun is really shining and it gets hot out. And then we do get a lot of algae. Even though we typically drain the tank every day, it doesn't matter. And it still builds up in there. It doesn't clog anything. As far as I know, it doesn't really cause any problems, but it might. So yeah, when it gets really bad, I try to scrape it out. It doesn't really get rid of it. It just steps it back for a little while. So yeah, it'd be nice if there was something that we could just put in the water without contaminating the water to keep that from happening, but I'm not sure what that would be.
Elizabeth has a full citation for that book you mentioned, Grass-Fed Cattle, How to Produce and Market Natural Beef by Julius Ruchel.
Perfect. Yeah, thanks.
That was it. And then one quick clarification question from John. What size polypipe? 1 inch, bigger?
Ours is 1 inch. Yeah, it's 1 inch HDPE. Yeah, I know people with more cattle than us have to use 1 1/4 inch or 1 1/2 inch. I think it just depends on how many cattle you're trying to water. If you're doing goats or something with a lot smaller water requirements, you could probably get away with 1 inch in a whole lot of goats, or sheep. But 1 inch has worked really well for us.
All right. Thank you so much, Dave. We'll let you go now to get on with your day. And thank you all for joining us. Please come back next week for our penultimate webinar of the season. Have a good one.